Good afternoon. It's my pleasure to share my views on machine-to-machine communication and Internet of Things and its application in the power sectors and other verticals. We will touch briefly these points, this TEC, M2M projections, applications, challenges, M2M standardization at international level, and the work going on in TEC and some of the use cases taken over in the documents which have been released. This TEC is the technical arm of the Department of Telecommunication, and in brief, if we say TEC is having a number of very important labs like IPv6 Ready Logo Test Lab, which will be quite useful for testing the IPv6 in the communication stacks, and all manufacturers can take the advantage of these labs in TEC. We are having a specific absorption SAR lab, NGN labs. A number of labs are also expected to come in the next 2 to 3 years, and which will be quite useful for the IoT domain. This is one of the slides taken from IERC. This is a European Research Center on Internet of Things handbook, released in 2015, showing the Internet of Energy, like it is having the different type of generating stations, like renewable, this solar, and this big plants and the consumers, using the all type of communication technologies. I have taken this slide to show that the technology can be used to have the data in real time, and the decisions can be taken to make the verticals smart. If we see machine-to-machine communication, it is basically the transfer of data from one machine to another machine without any human intervention. The human intervention, it is very important that the data is being transmitted without any human intervention. And uplink is used for data transmission and downlink for sending the instructions. This is one of the pictorial view of the machine-to-machine communication, and this device like the meter can transmit the data to head-end server through the transport network. If we go one step ahead, that is the Internet of Things. It will have machine-to-machine communication and machine-to-human communication. And it is very important that this IoT will consist of hybrid infrastructure of non-IP and IP devices connected with the IP gateways. All the gateways are supposed to be IP enabled, and the devices behind the gateway may be IP as well as non-IP. These are the projections already briefed in the opening remark by our senior DDG. So it is very important to note that the projections, either it will be 26 billion or 50 billion or in between. Hardly 17% of the devices will be the tablets, phones, and the laptop. Remaining 83% will be the conventional devices in various domains like in power, wearables, homes, automotive sector, and others. This is one of the very important slide taken from the research handbook of Cisco, that in 2020 the one person will be having around 6.58 devices, whereas the population of the world will be around 7.6 billion. If we exclude around 2 billion of the 2 billion population which will not be connected at all, then this average will be around 12 devices per person. So this is a very expanding field. And if we see the Indian projections, India will have around 2.6 billion connected devices by 2020, and this around 40% will be SIM-based devices, which was projected earlier, but now the figure may be quite less, and most of the devices will be on low power wireless or the wired broadband or lease lines. This power is a very important vertical, and out of this around 30 to 40% devices will be in the power vertical and the smart home and intelligent building segments. This machine-to-machine communication will make all the verticals smart, and the data which is generated from the sensors will work as a vital input for intelligence, for planning, management, policy, and decision making. And after all, the impact will be that the connected devices will improve the quality of life. This is so many verticals and so many, there may be large number of verticals and large number of applications which may be available in the M2M and IoT domain. These are the technologies, various technologies have been described by the previous speakers. These are various technologies, and utilities are free to choose any technology, but it will be better if the technology works, is interoperable and having the long life. These are Wi-Fi, Bluetooth, low energy, NFC in the cellular 2G, 3G, LTE. Now narrowband LTE is also expected to come in near future, and later on 5G. We can have PLC, narrowband PLC, wideband PLC, very much popular in the European countries. Low power RF, 6LoWPAN, Zigbee, Wi-SUN, and Z-Wave. Nowadays, LoRa and 6Fox, they are quite popular, and a number of companies are also importing LoRa chipsets in India. These are proprietary technology, but are required to be tested. LoRa Alliance has already made a tie-up with the ETSI. This embedded SIM, backbone RFID and backbone network may have the optical fiber cable in ring structure and this smooth Wi-Fi coverage. And also the offloading technology can be used with the Wi-Fi, which can provide this smooth coverage. Data centers will play a big role, big data analytics to create the intelligence and use of intelligence for different activities, and open APIs are also very important. Moreover, the ICT infrastructure can be used to create the vertical smart. This is one of the picture using the heterogeneous technologies. Challenges, these are some of the challenges in the M2M and IoT fields. This is lack of standards and the interoperable technologies. We need, as the sensors will be unmanned, these devices will be mostly unmanned, therefore low power consumption or the long life batteries is required, or we have to develop such type of technology which consumes less power, or the sensor remains in the sleep mode when they are not transmitting the data. Slow deployment of IPv6, the chipset should be cheaper, low cost devices are required, and most important, the security of the M2M and IoT domain is required. This standardization work is going on at the international level, that is 1M2M is working at a large scale, and first release from 1M2M has already come in 2015. They are working to create standards for the common service layer. From India, TSDSI is the member of 1M2M, and we can submit the contribution through 1M2M through TSDSI. ITU is the International Telecom Union, is having all the member states and industries as the members. Any standards approved by ITU is accepted globally. ITU has already created a study group 20 for IoT and its application is in smart cities and communities. Alliance for Internet of Things Innovation has been created around 2 years back in Europe. It is also a very important organization. So we can take the help of these organizations for developing or finalization standards for the Indian scenario. What we are doing in the Telecom Engineering Center in 2013, around multi-stakeholder working groups were formed. These were in automotive, power, health, safety and surveillance, gateway and architecture, and security of M2M domain. These are some of the very important members of the power working group in TEC. I will like to thank all these members and appreciate that by their efforts we have released 2 technical reports, and these are very important reports which have come up with a number of emerging points. These are ADAG, CDOT, Crompton Greaves, Cyan Technology, DOT Erection, ETSI, ISGF, Landis and Gear, Narnix Technolabs, ProCube Technology, Secure Meter, ST Micro, TCS, and TEC Texas Instruments, TSDSI, and Tata Teleservices. There may be some other organizations also involved in submitting the contribution in this vertical as well as also in other verticals. These are the documents released in May 2015 by Honorable Minister of Communication. These documents are available on TEC website. The National Telecom M2M Roadmap was also released by DOT. This is available on DOT website. These reports were sent to secretaries of the different ministries by the Secretary Telecom. New working groups were formed, and these were smart city, smart homes, smart village and agriculture, environment and pollution control, smart governance. In TEC we are having national working group that is similar to the study group 20, and with the by using these technical reports we have submitted contribution in the study group 20 for its meeting which was held in Singapore, and it was the effort of all the members of the this working groups that the documents were released. These second release was made in sometime in November 2015 and related to power, that is the spectrum requirement for PLC and low power RF communication. This document was released, and these documents, these are the action points emerged from the technical reports. This is really very important. That is the M2M network architecture and various service delivery models for providing services in the M2M domain. This is one of the point related with the gateway and architecture, as not a single entity can provide the entire M2M services. Various architecture have been shown in this document, and it has been sent to DOT for further consideration. 13-digit M2M numbering plan for SIM-based devices or gateways. Related with the power, this power spectrum for narrowband and wideband PLC, which is being used in India, it has been mentioned in the document. And another one, the spectrum requirement for low power RF communication. Last year when India Smart Grid Forum was held in Bangalore, there was a discussion for the spectrum for low power wireless devices, and this committee industry group has studied in the coordination of ISGF, and this report was studied further by the M2M working group members in TEC, and this 12 megahertz spectrum has been proposed for low power wireless devices, and it has been communicated to wireless WPC wing of DOT. They are examining this, further examining the slabs and other things, and we hope as a billions of devices will be available in the low power wireless domain, this spectrum will be required time to time, as the chipset will be developed for the at least for the next 15 to 20 years. So these are some of the slides taken from some books. Thank you very much.